The instructions say to factor. Excuse me, to factor the following expression. Okay. So our expression is, this is number 1, incidentally, I believe. Yeah, 1. X to the 5th minus 6x to the 4th plus x minus 6. It doesn't say how we should factor this. I'm going to tell you how. Often when there are 4 terms and you're being told to factor, you're going to factor by grouping in the following way. Parentheses around the first 2 terms and parentheses around the second 2 terms. And you want to have a plus sign in the middle. Okay. Let me make sure that everybody can hear me, okay? All right, I am, okay. I don't see that I'm muted. All right, cool. Well, here we go. I have 2 groups here. I'm going to treat them separately for a while. I am going to factor this set of terms by the GCF, and I'm going to factor this set of terms by the GCF. So, this is going to be x times x times x times x times x minus 6 x times x times x times x. Okay. And this is just x minus 6. In fact, there is no visible GCF to these terms. But is there? Yes, there is. There is always a 1. 1 is your best friend. Okay, so each of these terms in the first set of parentheses has 4 x's. So that is my GCF for the first set of parentheses. X to the 4th, parentheses, leftovers. I have an x leftover and I have a minus 6 leftover. So x minus 6. And then over here, because I don't have a GCF, I always have a GCF, and that's 1. So sometimes you just have to go for a 1. See, that's a 1 times x and a 6 times 1. So I conveniently found a 1 GCF. You can always do that. Now we consider the entire statement, algebra statement here, and notice that you have an x minus 6 and an x minus 6. And they're connected with a plus in the middle. And in fact, this is x to the 4th times x minus 6 and 1 times x minus 6, which makes this a term and this a term. And both terms contain an x minus 6. That makes x minus 6 the greatest common factor of the entire expression. So I'm going to write that, x minus 6, and then I'm going to write the leftovers. X to the 4th plus 1. That's the leftovers, x to the 4th plus 1. And this is the factorization of the original term we were dealing with, which was x to the 5th minus 6x to the 4th plus x minus 6. And I can multiply these two together and prove to myself that I'm correct. X times x to the 4th, x times positive 1, negative 6 times x to the 4th, negative 6 times positive 1. And that will give me x to the 5th. X to the 1 times x to the 4th is x to the 1 plus 4, which is x to the 5th. And x times plus 1, that'll be plus x. And negative 6 times x to the 4th, that minus 6x to the 4th. And negative 6 times positive 1 is negative or minus 6. Well, they're not arranged the same way, but when I put them in descending order, I'll have x to the 5th minus 6x to the 4th plus x minus 6. So that means that this is the correct factorization. Don't be fooled. You could factor x to the 4th minus 1. We haven't gotten to it yet. But you cannot factor x to the 4th plus 1. That's why I didn't do it. Okay, so I'm going to write the answer over here. Can't fit in the oh, I could fit in it, but I'm not going to take the time. Not going to take the time. So I have proved to myself I was right there. Let us move on to problem number 2, where again they've written in A's. What is it with these people? Well, I'm going to write as X's, and then I'll go ahead and rewrite it with A's. So number 2, I'm going to write it as x to the 3rd minus 3x squared plus 6x minus 18. All right, put parentheses around the first two terms, parentheses around the second two terms. You must have an x in the middle. Period. It's just the way it is. Now, you have x to the 3rd and you have x squared. Both of these terms contain an x squared, which you can see if you go ahead and write this as xxx, and this is xx. What you'll be left with is x minus 3. Now, 6 goes into 18, so that is very handy. This is 6x, and this is minus, well, okay, 6x minus 18 is 6x plus negative 3 times 6. Now both of these terms have a positive 6. So I factor that out to the front, and I'm left with x plus a negative 3, which is x minus 3. So that's what I've got here. All right, now, looking at the whole entire expression, I have an x minus 3 and an x minus 3. X minus 3 is the GCF. And what's left over is x squared plus 6. And then we check and make sure. Should have written it in black. Oh well. That'll give me x to the 1 times x to the 2 is x to the 3. X times plus 6 is plus 6x. Negative 3 times x squared is minus 3x squared. And negative 3 times positive 6 is negative or minus 18. And to make this look like my original line, I have to write it in descending order. X to the 3rd minus 3x squared plus 6x minus 18. And so, yes, if I'd written it with A's, that would be what I would have. So don't forget that you have to rewrite it. A to the 3rd minus 3a squared plus 6a minus 18. And I'm going to put that in a blue box. Because that is going to be your answer. And I should have written this in a blue box, but I wrote it in a black box. Any questions about these two problems? Notice all four, all two, yeah, you see. All right, both problems have 4 terms each. I group the first 2 terms together. I group the second 2 terms together. But the important thing is to have a plus in the middle. We must always have a plus in the middle. Once you have that, you factor the first 2 terms, the first set of parentheses, by GCF, and the second set of parentheses by GCF. If your polynomial is factorable, then you've got matching parentheses on each side of your plus sign. You've got, I should have said factors. You've got matching factors on each side of your plus sign. Here you had an x minus 6 and an x minus 6. Here you had an x minus 3 and an x minus 3. And then you pull that out as a GCF and write the leftovers. These are basic grouping problems, and let me write that at the top. These are called grouping. Well, all right, wrote it in blue. Grouping, because we are grouping. What am I grouping with? Parentheses. That's one of the most important jobs of parentheses. Parentheses do a number of different things, but one of the main things they do is they group terms together. And remember, this is just a method, so there's no deep thinking that goes into it. If you're somebody who finds it boring to memorize methods, well, sometimes you just have to do that. When you get up to calculus and stuff, you're going to start using some intuition, if you can prove it's true. All right, let's see what comes next. Another one of these, but with a complication. There has to be a complication. Otherwise, life would be too boring. Might as well have that attitude. Life is full of complications. And just to make sure I don't miscopy it, let's go ahead and cut and paste that over here. Right there. There we go. Perfect. Now it says to factor these guys by grouping. Now watch carefully. The first two terms are never a problem. I say never. There's probably a time when they are. When I leave a space like that, you know I'm up to something. We have to have a plus sign here. That's the invisible plus sign. Let me make this bigger. That's the invisible plus sign that goes in front of the minus or negative 7. So I haven't put anything in there that wasn't already there. Now over here, this is going to be easy enough. Over here, this is x times x times x. And this is plus 5 times x times x. Both of these terms have an x squared. So I pull that out to the front. And then write the leftovers. We have an x plus 5. We're done with easy. Say goodbye to it. Actually, it's not hard. It's just, it takes thought. Here we have, now that it's grouped, a separate polynomial, negative 7x minus 35. This is the higher degree term. This is a degree 1 term. This is a degree 0 term. This is the leading term, and negative 7 is the leading coefficient. -7 is negative. Pretty perceptive of me. So, the GCF for this set of parentheses is going to have to be negative. I know that 7 goes into 35. That's not a problem, but my GCF cannot be 7. It's going to have to be -7. So I'm going to have to rewrite the terms in this set of parentheses. Here we go. Also, remember, there's an invisible plus sign here. This is -7x plus -35. Just so you know, I'm not putting in anything that's not already there. -35, I've got to have a -7, so it's going to be -7 times +5. That's the only way I can get -35 and still have a -7 to pull out. Now I have -7 in both terms as a GCF. Right there. So I'm going to write it in front. And then write my parentheses. And write the leftovers. I have an X left over. And I have a +5 left over. So I'll use that plus sign. I will have X plus 5. The whole problem depends on my remembering the fact that if the leading term is negative, the GCF has to be negative. Now, I have my GCF for the entire expression. It is X plus 5 here and X plus 5 here. I pull out X plus 5. And then I write the leftovers. X squared plus -7, which is -7. Could I factor that? For those of you who know the difference of two squares, we haven't gotten there yet. We're gonna. I could, but I'd have a square root of 7. I don't want to have the square root of 7. So, we're going to factor by grouping, and I'm going to look at, oh, there aren't any instructions. Enter your answer in the answer box and then click answer. Check answer. Okay. So, yeah, that's it. Now, if that was a 4, maybe. Well, definitely you would. So instead of talking about this, let's just go to the end. I'm going to go to the last page here. And I'm going to show you some factoring by the difference of two squares, so I'll shut up about it. If you have two perfect squares, let's make one. How about 16x squared minus, gotta be a minus, 25. There's a special way to factor this. Here it is. This is 4x squared. And this is 5 squared. That's why I wrote it in brackets like this. Just because I didn't want to write parentheses in parentheses. Okay, I can factor that in a particular way. That's very easy. I love problems like this. Write the 4x and the 5 there, and the 4x and the 5 here. And then put a plus in front of one and a minus in front of the other. And lots of years of doing math have taught me that it's easier in the long run if I put the plus in the front set of parentheses. You don't have to, but I'm just telling you it'll be easier for what you use this for. Let's do another one. X squared, let's just use x squared, minus 81. Okay, x squared is x squared. It's a perfect square. 81 is a perfect square because it equals 9 squared. So I put x and 9 and x and 9. There you go. Now I want you to watch one more thing. X to the 4th minus 81. Okay. Well, this actually is perfect squares. This is x squared squared minus 9 squared. So this is going to equal boom, 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 boom. X squared, 9, 9 plus minus. Boom, watch out. Because this, well, first, this is prime. You cannot factor that. Not over the real number system. And that's the one we like. And x squared minus 9, those are perfect squares. This is x squared minus 3 squared, positive 3 squared. But I'll write it with parens anyway. That means this can be factored like this. So it ends up that x to the 4th minus 81 has 3 factors. X squared plus 9, x squared, x plus 3, x minus 3. And that's why it's just neater to put your minus in the second place, because if that one is going to be able to be factored, you still have room. If it's in front, well, I always like to put my minus behind. Okay, that is the difference of two squares. Notice that if you have the sum of two squares, there's no way you're going to factor that and get numbers that are in the real number system. Can it ever be factored? Not at this part of the semester. Next week, maybe.
Professor?
Yes.
Did we start off with x squared minus 81?
Yes, and it just factored like that.
So why down below on the third line does it say x to the fourth minus 81?
Well, because I rewrote the problem. This is how it would be different. X to the fourth is x squared squared. So you end up, yeah, you end up writing it like this, and then boom, it ends up that can be factored by the difference of two squares.
Okay, very good, thank you.
You're welcome. Good, thank you for asking. Other questions? Okay, let's go back to grouping. Anyway, this 7 is not a perfect square, so it's not something that we would normally factor. There are some circumstances when we would, but not now. You'll know when. And it hasn't arrived yet. Okay. Now here we go. This is number 4 in your homework, where we put all this stuff together with the AC method. Again, we're just talking methods. The whole matrix thing was just methods. A method. All right, the AC method of grouping. Here is problem number something. Problem number 4. Okay. First thing I have to do is turn it around the right way, descending order, because this is degree 2. This is 2. This is degree 0. And this is degree 1. And the sign always goes with the number or the letter behind it. So what we really have here what's really going on, what's invisible, is you've got a plus sign here, and you've got a plus sign here. And you know, if I had a problem like 3 plus 2 equals 5, you would automatically know, you wouldn't even think anything about it, that, well, 3 plus 2 is the same thing as 2 plus 3. I could write it as 2 plus 3 if I wanted to, because when numbers are added, you can move them around. Which is why it's so valuable to look at polynomials as being separated, the terms in a polynomial being separated by plus signs, so you can move these little cuties around. 12v squared plus negative 8v plus negative 32, which is 12v squared, plus times minus is minus, minus 8v, plus times minus is minus, minus 32. That's why we can move terms in a polynomial around to suit us. That's why we can combine like terms. So it's not a magical mystery tour, really. All right, so I'm kind of putting off doing it because this is challenging. No, not challenging. First, notice, please, that this is a quadratic trinomial. And then notice, please, that there is a GCF hiding in there. The number 2 will go into these numbers. The number 4 will go into these numbers. Who knows how many numbers can go into it? So let's break them all down completely. So I'm going to do that right now. Forget the equal sign. Oh. What happened to my toolbar? I want my toolbar. There. Will scare me next time. No, don't. Let me erase the equal sign. Remember way back in pre-algebra, some of you don't remember way back. I barely do. But that's because I use it all the time. And I used to teach it here. 12, one of the easiest ways to break down numbers is to make a factor tree, because you can think of any two numbers that multiply together to equal 12. Like, I could think of 3 times 4, or I could think of 2 times 6. It doesn't matter. 6 breaks down to 2 times 3. 2 and 3 are prime numbers. They won't break down anymore except fractions. And we don't do that. Nice girls don't do that. Okay, so 12 equals 2 times 2 times 3. 8, forget the negative sign. 8 is 2 times 4, and 4 is 2 times 2. So 8 is 2 times 2 times 2. And 32, what occurs to me right offhand is 4 times 8. But something else that 32 equals is 2 times 16. It doesn't matter where you start. 4 times 8, 4 breaks down into 2 times 2. 8 breaks down into 2 times 4. 4 breaks down into 2 times 2. So 32, oh my goodness, breaks down into 2 times 2 times 2 times 2 times 2. My goodness. Hyperactive in the 2 way. Okay, so let's break this down. I better start out here. 2 times 2 times 3 times v minus, or let's, oh no, minus 2 times 2 times 2 times v minus 2 times 2 times 2 times 2 times 2. Goodness. Now, each of these has at least 2 2's. So we could have gone with 4. But if you're not sure, this is the best way to break it down. All right, so 4. So I'm going to pull out 4 as a common factor. This term doesn't have a v, So it's not going to have a V in the common fact. The quadratic trinomial is not going to have a V in the GCF. Now the leftovers, 3V squared minus 2V minus 2 times 2 times 2 is 8. So this is what we're going to be dealing with for parentheses 3V squared minus 2V minus 8. Where this is a quadratic trinomial, but A does not equal 1. In fact, I can write over here that A equals 3, B equals -2, and C equals -8. Be careful, remember the invisible plus signs.
I'm sorry, I think I missed where the 8 came from.
4, 2 times 2, came out of this term and I was left with 3 2's. 2 times 2 is 4 times 2 is 8.
Okay, I got it. I'm sorry.
No problem. No, don't be sorry. I'm glad you said that. All right, so now here is the AC method. You use it when the A number is not positive 1. A, I'm going to write it real big again, is 3, B is -2, and C equals -8. It's called the AC method because I'm going to multiply A times C. A times C is 3 times -8, which is -24. Now, after I've got that, I factor -24 into factor pairs that add up to the B number -2. So here I go. -20. I want to pretend it's positive first. I always do that because it's just easier. I also wrote it too small. Okay, let me come on up like this. 24 equals 1 times 24, 2 times 12, 3 times 8, 4 times 6, 5, no, and then 6 times 4, so it starts again. But it's -24, not +24 that I'm dealing with. So here I let the first number be negative, and then I come over here and I write the pairs again, but I let the second number be negative. Okay, now I look at these and I ask myself, where do I find a pair of numbers that add up to -2, the B number right here? And the answer is, well, -4 plus 6 equals +2, but 4 plus -6 equals -2. Bingo! All right, what am I going to do with that 4 and -6? It's a little more complicated now. So let me write this out. I don't want to lose my 4. Now I'm going to write 3v squared, and I'm going to write -8. But now, -2v, the middle term, splits apart into 2 other terms so that I have 4 terms so that I can do grouping. And here are the numbers I'm going to use. The 2 numbers that equal the B number, because they're going to equal this. Now, notice that I could write +4v -6v, but 4 and 3 have nothing to do with each other, and 6 and 8 do share a 2. But if I turn them the other way, remembering that it's okay to do that as long as you include the sign, then here is what old smarty me is going to do. I'm going to put my -6v here. There's the -6. And +4v here. Now, -6v plus 4v is -2v. Very cool. That's the AC method. Now I'm going to use grouping. Parentheses, parentheses. And because I have -4 out here, I'm going to put a bracket, and I'm going to put a bracket, because I'm going to be doing lots of stuff to these. I'm going to do the whole grouping thing. Okay, so I'll have 4 bracket paren. 3v squared is 3 times v times v minus 2 times 3 times v. Oops, there. And over here, I'm going to have 4v minus 2 times 4. Notice I made sure that since that 4 is positive, the 4 over here is positive. And this isn't a minus sign, this is a times times. Okay, times sign. Now, I can see that these 2 terms, right? I do the first set of parentheses first. A 3v and a 3v. 3v is going to be the GCF of these 2 terms. So I'm going to have 4, pull out the 3v, and what I'm left with here, hello George, is v minus 2. Now plus, oops, I didn't close my bracket. The math police are going to get me. I have a 4 over here and a 4 over here, I can't say 4V because there's not a V over here. So just 4. 4 is going to be my GCF for this set of parentheses. And the leftovers are V minus 2. Perfect. I'm on a roll here because look, the V minus 2 matches the V minus 2. That's kind of a check to say I'm on the right track. So here's 4, hasn't been used yet. Well, it's not going to be used, we pulled it out. Bracket, bracket. This V minus 2 is now the GCF for the entire expression in the brackets. So I write it out front, V minus 2 times the leftovers, 3V plus 4. And now I have the factorization of 12V squared minus 8V minus 32. So let me write it all out. 12V squared minus 8V minus 32. I hope I wrote that correctly. Yes. Equals 4 times V minus 2 times 3V plus 4. And that's what I have every intention of writing in the answer box. But before I do that, we might as well check. Because it's an awful lot of work. Oh, all right. All right, yeah. Talking to my computer. Check. Four times. I'm going to put my brackets back. And I am going to multiply V times 3V. Hello, George, come on up. Excuse me a minute. My child needs attention. Come on. Come on, say hello to your friends. There you go. Yeah. Get comfortable. That's right. Yeah, got him. The butt is always the problem. Okay, all right, yeah, here we are. As I was saying, V times 3V, V times 4. Yes. Negative 2 times 3V, negative 2 times 4. That's what I'm going to put in here. V times 3V is 3V squared. V times plus 4 is plus 4V. Negative 2 times 3V is minus 6V. And negative 2 times positive 4 is negative or minus 8. Okay, I'm going to combine like terms first. 4. I'm just going to change that to parentheses. I guess I didn't need brackets. 3V squared. 4V minus 6V is negative 2V minus 8. And then I distribute in the 4. 4 times 3v squared, 4 times negative 2v, 4 times negative 8 is going to give me 12v squared minus 8v. Yes, minus 8v minus 32. So yes, and it's even more correct than the first line, because they, after all, are not in descending order, and I am. That, ladies and gentlemen, is factoring this quadratic trinomial by the AC method. But first you had to pull out a GCF. Notice that. Always pull out your GCF first. We had a 4 GCF. And sometimes you have to go to a lot of trouble to figure it out. Sometimes you can just look at it and see what the GCF is. But it's got to be the biggest, the greatest common factor. So 2 would not have been correct because 4 is bigger than 2, and 4 goes into each of these numbers. You've got to choose the biggest common factor. Okay, now I know this is awe-inspiring. My reaction when I was a student was, ha, you've got to be kidding. But yeah, so I do know what you're going through, some of you. This is the same kind of problem. You can see we're going to have to pull out a GCF first. However, let us do it. Let us do it because we are so tough. Number 5 in your homework. 40r squared minus 62r plus 24. Okay. Make absolutely sure I wrote that down correctly. All right. Now, 40, let's break them all down. Let's do this thing. Do it right. 4 times 10, or you could say 8 times 5. It just doesn't matter where you start. You just keep breaking down until you can't break down anymore. 4 is 2 times 2, and 10 is 2 times 5. So 40 equals 2 times 2 times 2 times 5. 62, don't worry about the sign, not right now. 62, I know that's going to be 2 times 31. Really? 31 is a prime. So that won't go any further. Really? 4 won't go into 62? I guess not. No. Okay, well, 24. There's almost no reason to do this. What is that? 4 times 3. 2 times 2. So 24 is going to be 2 times 2 times 2 times 3. You have all these 2's and this guy is limiting us. It's just not right. Oh. So let's just write it out. 2 times 2 times 2 times 5 times r minus 2 times 31 times r plus 2 times 2 times 2 times 3 and no r. Okay, it looks to me like one stinky 2 is going to be all we can pull out. Okay. All right, well, I've had my little temper tantrum. So I pull out a 2. Here, let's go ahead and mark a 2 to pull out. And pull it out. Two times 2 is 4 times 5 is 20. R squared minus 31R plus 12. Oh, I hate big numbers. But we must do what we must do. Our A now is going to be 20. Our B is negative 31. And our C is 12. So A times C is 20 times 12, which is 240. Well, I have every intention of pouting. Okay, it's time to learn a calculator technique that makes this a little easier when your numbers get so big you really don't want to use them by hand. Do them by hand. Here it is. Take notes. Go to y equals. You're not going to be graphing. But this is what we're going to do. We're stuck here with 240. Type 240 into y1. Divided by, and put an X here. Remember, we're not going to graph. Instead, we're going to push the second button and the graph button. Second graph will not graph. Second graph gives you a list of the factors of 240 because we said 240 over X. Now, I need negative 31, but let's just find something that could add up to 31. See, once you start getting decimals, you throw those out. You don't even think of them. Now remember, if I take one minus the other, what will give me 31? And then they start to repeat. So yeah, I need to add them so they'll add up to 31. So what adds up to 31? That's 38. That's 34. That's 32. That's 31. I was so afraid we weren't going to find anything. Okay, Now I can pretend I knew it all along. AC is 240. If we want numbers that will add up to a negative number, then both of our factors have to be negative. Now this says that 240 equals 15 times 16. I never would have pulled that out of the air. All right, 15 times 16. Let's make sure. 15 times 16 is 240, okay? And 15 plus 16 is 31. But we need the negative version. Since 240 is positive, we know that negative 15 times negative 16 will also equal 240. If you don't believe me, look. Negative 15 times negative 16 is positive 240. Negative 15 plus negative 16 is negative 31. Woo-hoo! Okay, enthusiasm. Well then, here we go. Negative 31 is going to split apart. 20r squared stays the same, and 12 stays the same. But negative 31r is going to break apart into negative 15r, negative 16r, which is you take away 15 r's, then you take away 16 r's, you've taken away 31 r's. I need a drink after that. That was good work. Woo! Okay. Okay. Now. Two. Bracket. Parenthesis. 20r squared minus 15r. Parentheses close. Let me make it bigger to make sure you can see it. That's just a 2. All right, now plus has to go here. And then negative 16r plus 12, parentheses closed, bracket. Excuse me, closed. Here we have a negative leading term. Our GCF is going to have to be negative, but I'll worry about that later. This is something I need to figure out right now. So I've got 20 and I've got 15, and I know 5 goes into both of them. So, and there's an r squared and an r, and I know r is part of both of them. So, I'm going to have, let me write it out, 5 times 4 times r minus 3 times 5 times r. Okay, both of these terms have a 5 and have an r, and a 5 and an r. So 5r is going to be my GCF. Let me come down one more row. See, the first one's always a little easier. 5 and an R is going to be my GCF. And then I write the leftovers. I have a 4 left over and an R left over, minus a 3. Okay. And now a plus and a plus. I go back up. Now 16, forgetting the sign for a minute, 16 and 4, both are divisible by 4. That is, 4 goes into them evenly. So let me write it down like this. Negative 4 times 4R plus, now, when the leading term is negative, the GCF has to be negative. That means I have to pull out a negative 4. So I have to change 12 to negative 4 times negative 3. Because negative 4 times negative 3 is positive 12, but that gives me the negative 4 that I have to pull out because my leading term is negative. So let me take care of that now. I've got negative 4, and I've got negative 4. That's going to be the GCF of the second set of parentheses, which I didn't close. Bye, George. Okay, I pull out negative 4 as my GCF. And then what's left is a 4R here, plus a negative 3. Plus times minus is minus 3. That's what I've got right now. All right, that minus sign here looks kind of sick. Where'd it go? Oh, there. All right, now notice that inside the brackets here, 4R minus 3 is going to be my GCF. So I have 2. I have 4R minus 3, and then parentheses leftovers. 5R plus a negative 4, plus times minus is minus, so this is going to be 5R minus 4. And, I mean, I could close the bracket, but actually, notice I don't need the bracket now because everything is multiplied. And I don't have to worry about getting the 2 mixed up with the other stuff. So let's go ahead and check. I'm basically going to go backwards. I've got a 2, but what I want to do first is multiply 4R minus 3 times 5R minus 4. So 4R times 5R, 4R times minus 4, minus 3 times 5R minus 3 times minus 4. And I'm using minus instead of negative because they are minuses, and I don't want you confused. It may happen. Okay, 4R times 5R is 20R squared. 4r times minus 4 is minus 16r. Minus 3 times 5r is minus 15r. And minus 3 times minus 4 is plus 12. Let me combine these like terms. All right, that's going to be 20r squared minus 31r plus 12. Now I distribute in or multiply the 2 times all 3 terms in parentheses. I'll have 40r squared minus 62r plus 24. And I'm going to look up here and see if that is what I started with, 40r squared minus 62r plus 24. Yes, so that means that this is what I'm going to write in the answer box. These are involved. There are lots and lots of steps. But just like life, grown-up life, grown-up math, there are lots and lots of steps. Ugh. Ugh. Okay, all right. Okay. 2 more. We can live through 2 more. All right, here we are going to factor the following trinomial. There it is. Number 6. Number 6. 75x squared plus 55x plus 10. Okay, there we go. Now, 75 looks more like 76, so let me cure that. There now, that's better. Obviously, 5 goes into all of them. And I think that's all we're going to get out of them. So we can pull up our calculator and say, and move this over here. 75 divided by 5. Is 15. So 5 times 15 times x plus, I know that one, 5 times 11 times x plus 5 times 2. Yeah, 5 is the only one. Okay. So 5 is what we're going to pull out as our GCF. You don't always have a GCF in the very beginning to pull out, but on these problems you do. So we pull out a 5, and that leaves us with 15x squared plus 11x plus 2. All right, now this is a quadratic trinomial, 15x squared plus 11x plus 2. And that, because a is not 1, it's 15, this is what I'm going to have to factor by the AC method. So a is 15. I should write it down here, not up there. A is 15, B is 11, C is 2. I multiply A times C and we get a decent number this time, 30. Well, I can take care of factoring that. Positive 30. So we'll have 1 times 30. Well, except it's ugly. Let me roll this up. 1 times 30, 2 times 15, 3 times 10, 5 times 6, and then it starts to repeat. And notice that our B number is a positive number, so we don't really have to write the negative factors over here unless you just want to be complete. So 5 plus 6 equals 11. So we're going to go with 5 and 6. 11 is going to split apart. 11x is going to split apart into 5x plus 6x. So 5 times 15 x squared plus 5x plus 6x plus 2 is still 15x squared plus 11x plus 2. So numerically, I haven't changed it, I've just changed the form of the trinomial. Form, not substance. Okay, I gather the first two terms together. And the second two terms together. Now this is pretty easy compared to the other two. Because, I mean, 15 is a familiar number. Probably you don't even have to write out. You don't have to do this part because you can probably do it in your head. But, I mean, this has 5x, that has 5x. If you don't want to get all messed up, you should put in a times 1. Plus 2 times 3 times x plus 2. Once you pull the 2 out, there won't be anything here. You might be tempted to write a 0. Don't do that. Remember that 2 is 2 times 1. Let's protect ourselves. Kind of insurance. 5, bracket. Here's our 5x. Well, no. 5x is your GCF. And what you're left with is leftovers. 3 times x plus, there's a 1 left over, which is why I put it there. And over here, you've got a 2 in each term. We're going to pull that out. And you're going to be left with 3x plus, and there's your 1 right there. All right, notice how sometimes they're easier, sometimes they're harder, but the AC method is always alike. I mean, the steps you're following are always alike. So now, in the brackets, in the world of the brackets, 3x plus 1 is your GCF. And then the leftovers are 5x plus 2. And so, here is the answer I would put in the answer box. And let's just let the proof go. No, 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 never mind. Okay, now down on this page is where, yeah, I put all that difference of squares. Okay, so let me draw a line here. And the final problem is going to be a U substitution plus AC method problem. Talk about putting it all together. Oh, yeah, I can just do that. I could just take a picture. Factor the following trinomial. Oh. I'm wilting quickly. There we go. Okay. Yeah, it needs to be bigger than that. All right. Here we are. 4v to the 6th plus 21v to the 3rd minus 49. Automatically, you should see that 6 is 2 times 3. So you're going to be using U substitution. U sub. No, I don't. U sub. Okay. So before we do anything else. Well, don't skip steps, Barbara. That's always a disaster when I do that. U equals V to the 3rd. U squared equals V to the 3rd squared. And when you have a base raised to a power again, you multiply the powers. V to the 6th. So I know I can rewrite this as 4u squared plus 21u minus 49. There is no GCF there, is there? Okay. Well then, we are going to have the joy of using the AC method. Four times negative 49. Yeah, let's get the calculator. 4 times negative 49. Negative 196. Okay, I think that is big enough for us to use the calculator. I'm going to y equals. Let me see if I can make that bigger. No. All right. Y equals clear. This time I'm going to say negative 196 divided by x. Graph. Don't hit enter, hit graph. No, I don't care what it looks like. Hit second graph. There. That's a lot better. Okay, let us go back to the very beginning here because there, back to error message. There. Okay. Now, I forgot what I'm looking for. I want two numbers that will add up to 21. Okay, that's a negative and a positive, adding up to 21. Okay. Now, whenever you see decimals, you don't even pay attention. So we'll have 4u squared and minus 49 and positive 21u is going to break up into positive 28u minus 7u. And that's what we have to work with. I put parentheses around the first two terms, parentheses around the second two terms, and then a plus in the middle. Now I break down the first set of parentheses. This is 4 times u plus 4 times 7 times u plus, this one's harder, because when you have a negative leading term, what can I say? You've got to have a negative GCF. So we'll have negative 7u plus negative 7 times positive 2. Okay, so over here, each term, that didn't feel right. For u times u plus 7 plus That's not for... Someone stop me before I kill again. It's minus 49. There. Plus 7, negative 7 times positive 7. That's what negative 49 is. Now I pull out my negative 7 GCF and I will be left, wait, let me circle these. Right there, that's the GCF. And then I'm left with U plus 7. Okay. Now, U plus 7 is the GCF for the entire expression. And the leftovers are 4U plus negative 7, which is minus 7. Now, as I was saying, the danger is feeling like I'm done. And I wouldn't put that past me. But having made this mistake before, as a student and even as a teacher, I know that I had better go back and resubstitute, namely that U equals V to the third. And this whole problem was written in V's, not in U's. So, since U equals V to the third, I'll go V to the third plus 7 times 4V to the third minus 7. And now I'm going to check it. V to the third plus 7 times 4V to the third minus 7. V to the third times the first term, V to the third times the second term, plus 7 times the first term, plus 7 times the second term. Okay. V to the third times 4V to the third is 4V to the 3 plus 3, which is 6. And V to the third times minus 7 is minus 7V to the third. Plus 7 times 4V to the third is plus 28 V to the third. And 7 times negative 7 or minus 7 is minus 49. And when you combine your like terms, what do you know? You get 4V to the 6th plus 21V to the third minus 49, which indeed is what we started with. So we lived through it in spite of myself. But more to the point, in all seriousness, the AC method can be difficult. So it would make perfect sense to me if you have lots and lots of questions about what we've done, especially this second half of the class. So let me make this just a little smaller. And open up the floor for questions. Oh yeah, and these. Somehow or other, I left them out of the homework, so I'm going to put a little homework assignment in right after the two big assignments that deals with this. Little assignment, as in 3 or 4 questions. Discussion, y'all.
I have a quick question about last week.
Last week, ancient history.
Yeah, I didn't get my homework finished from last week. Is there a way I can finish that up this
You can
week?
still go in and work on it.
Okay, perfect.
It's going to be open until the 15th, February 15th.
Okay. Thank you.
You're welcome.
Thank you for doing those other ones.
You're welcome. You're welcome. I don't know how I could have left him out.
This makes sense to
Well,
me
yeah, I
a
did.
lot more than the previous homework. This seems to make a lot more sense to me.
Oh, good. I'm glad. I am glad. Thank you for saying that. Anybody else? Well, okay. Hey, guess what? Class is over. You've got more than enough to think about. Because even if you know how to do all this and you remember how to do all this, that doesn't make it easy. But you're going to be doing lots of factoring, like I said, for the rest of the semester. It's just a part of it you never get rid of. And then you're going to find out, that there really is no such thing as a prime polynomial, a polynomial that cannot be factored. If we open it up to the complex number system. So next week we're going to be reviewing complex numbers. And I think solving quadratic equations by factoring and by the quadratic formula. So there's a lot of stuff coming. So if there are no questions, I'll see you during the week if you need to come talk to me, or I look forward to reading your emails. There are bound to be some questions, and I'm still grading papers. Okay?
Okay, thank you.
Thank you. But I'm glad to stay around if you have questions. In fact, right now I'm going to be saving this document after I save the writing on it. Okay, saving it to your class.